The following is the description of the super-synchronous mission flight profile of the ILS Proton launch vehicle with the IntelSat 22 communication satellite on board. The first three stages function to propel the orbital unit to a suborbital trajectory. The orbital unit consists of the BREEZE-M, payload adapter system, and the IntelSat 22 satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level, which is equivalent to the thrust power of 9 Airbus 380 commercial jets at takeoff. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its flight launch azimuth to 61.3 degrees in order to achieve a parking orbit inclination of 51.5 degrees as it travels eastward. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then the first stage separation occurs. The second stage engines follow with nearly 540,000 pounds of thrust for 3.5 minutes, and then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after third stage ignition, high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude and is moving about 7,300 meters per second or 4.5 miles per second relative velocity. The upper stage of the ILS Proton rocket is called the BREEZE-M and is designed to inject payloads into a wide variety of target orbits. The first BREEZE-M burn occurs about a minute and a half after the third stage separation, when the orbital unit is still in a suborbital trajectory. This will last long enough to achieve a low Earth circular parking orbit of 173 kilometers. This 4.5-minute burn spans from Siberia to Russia's east coast. The second BREEZE-M burn for the IntelSat 22 mission occurs about 1.5 hours after the first burn main engine cutoff and centers the descending node of the second orbit. The resulting elliptical orbit is called the intermediate orbit. This 19.5-minute burn spans from the southern tip of the Japan island chain to 600 miles northeast of New Zealand. 3 hours, 13 minutes after the second burn, the third BREEZE-M burn starts. Soon after this burn shuts down, the depleted auxiliary propellant tank is jettisoned, and the fourth BREEZE-M burn begins. The resulting orbit is called the transfer orbit, where the apogee is greatly increased to a super-synchronous altitude of 65,000 kilometers. These two burns add up to almost 18 minutes and span from the western side of China to the southeast side of Australia. During the coast phases, the BREEZE-M performs attitude maneuvers in order for IntelSat 22's solar arrays to be exposed to the sun at a predetermined solar illumination angle, which is designed to satisfy its thermal and power requirements. 10.5 hours later, during the fifth and final BREEZE-M burn, the orbital unit will perform a large plane change maneuver from 50.5 degrees to 28.5 degrees inclination and increase its perigee to about 3,800 kilometers in a 3.2-minute burn. About 12 minutes later, the IntelSat 22 satellite is separated from the BREEZE-M to reach its targeted supersynchronous transfer orbit. The total mission time from launch to IntelSat 22 spacecraft separation is approximately 15 hours and 30 minutes.